Hey everyone, welcome back. Today we're going to cover a scary topic for many general chem students, scientific numbers. This is where topics start to repeat in the future. As we see here, we have a level 1/2 difficulty, and this means you need to practice a little bit to succeed at this. Make sure you understand scientific numbers very well, be back in lab, and come into play almost every long answer test question. Without further ado, let's understand scientific numbers. To understand this concept, we need to know what uncertainty is. In the real world, we don't pay much attention to uncertainty, but here it means everything, quite literally. Uncertainty in this case represents how unsure you are of a true value of a number. In other words, if you have a ruler that measures to the nearest inch, you would be uncertain of the true value of the thing you're measuring. Is it 3.1 inches or is it 3.4 inches? You have no idea. With that being said, in Gen Chem you're going to run into two types of numbers: exact numbers and measured numbers. The difference between them? Uncertainty. Exact numbers do not have uncertainty, while measured numbers do have uncertainty. Let's start with exact numbers. There are two types of exact numbers you're going to run into. One are defined numbers, an example being a fortnight, these always have 2 weeks, or something like a mile, these always have 5,280 feet. The other type of exact number is counting discrete objects number. For example, 3 iPads or 3 loaves of bread. I can count 3 iPads, so this is an exact number. Now, there is one exception with defined numbers when looking at them in the context of exact numbers. Thing is, when we're converting from, like, say, imperial units to metric units, these are measured numbers. We can't really call them exact because they don't have an exact conversion rate. Now let's go into what measured numbers actually are. This is basically every value you get from measuring something. And as explained before, this will always have uncertainty. Let's take a beaker for example. Here we have a beaker with some liquid. We also want to measure at the lowest point of this curve, the meniscus. Now we know that this is less than 2, but it's also greater than 5. But I might say this is 1.6, you might say it's 1.5, and someone else might say it's 1.6323 milliliters. We don't know who is right, and that's sort of what uncertainty is. Now, what this means is when you write a number, how you write it is important. 1.5 is different from 1.53, and how you write a number is how uncertain you are of said number, and that translates to how much error each number carries. Now, the method we use to communicate uncertainty is called significant numbers. The idea is that the last digit is uncertain, and the rest all matter. The context of exact numbers versus measured numbers. Exact numbers would have unlimited sig figures, while measured numbers, that's what we're doing this whole significant numbers for. Now, it's not important to know why or how significant numbers works, but rather what the rules are and how many significant numbers you can calculate. So, here are the rules. Step 1, ignore all the zeros to the left of the first digit. Step 2, ignore all zeros to the right of the last digit, unless it's after a decimal place. And step 3, all remaining digits are significant. Now let's apply this to an example. Here's a number. Let's first ignore the zeros to the left of the first digit. Let's now ignore the zeros to the right of the last digit. Oh wait, there's a decimal place, so we keep them. All the rest of the digits are significant, and that's all. These are how many significant numbers are in this digit. Now there is one exception to this rule. Let's look at this number, 100. Right now, according to rules 2 and 3, the only significant number is 1. However, if we add a decimal place here, then we have 3. This only works for trailing zeros, and not really for anything else. Now, if you only want 2 significant numbers, just write it in scientific notation. Now, on your first test, you will be tested on how many significant numbers there are in a number, as well as rewriting numbers to those significant numbers. You want to practice this skill. Make sure you do because it will come back even after the first test. Now, the other thing related to significant numbers is calculating them through calculations. Now listen, you'll only need to know addition, subtraction, multiplication, and division. These are pretty simple. Let's look at multiplication and division. For this, the only number of sig figs is equal to the least amount of sig figs calculated. So if we multiply 2.1 times 2, we'll only have one significant figure, making the answer 4. For addition and subtraction, it's based on decimal places. For 2.1 minus 2, we get 0 because 2 has 0 decimal places. As for problems with mixed operations, you will need to calculate the number of significant figures for each step you do. So if you do addition then division, then you'll have to calculate the sig figs from the addition, and then you have to calculate the sig figs for the division. There's no way around that, that's just how you're supposed to do it. The final thing we're covering today is units. To make this simple, for Gen Chem everything's the metric system. Now remember this always, write your units on all numbers. Let me repeat that again. Write your units on all numbers. Otherwise you'll lose easy points. Anyways, I've written down the prefixes you need to memorize. The way it works is you scale these prefixes to the unit value. So basically 1 kilometer is 1,000 meters and 1 centimeter is 1/100th of a meter. You'll most likely use all of these skills on a calculation word problem. So once again, I suggest you practice. That's all you need to know. Good luck and happy studying.